Okay, these are the last three problems of the review, starting with number 5. So we've got a geometric sequence. Let's remember that it's geometric, and the common ratio is 1/2. That means that we are multiplying by 1/2 each time in order to get the next value. And so if we multiplied 8 by that common ratio of 1/2 to get the next value, which is 4, we can see clearly that a is equal to 4. Let's find the value of the 8th term. And so the 8th term in a geometric sequence we know we can find by taking the first term and multiplying it by r to the power of 7. In our case then we're taking 8 and multiplying it by 1/2 to the power of 7. That's going to give you then 8 times 0.5 to the power of 7, and we get 0.0625. And it says to find the sum of the first 12 terms. So we're looking now for the sum of the first 12 terms. This is a geometric sequence, so we have to use a geometric sum formula. So that's going to be u1 times r to the power of n, 12 minus 1, all over 1/2 minus 1, the r minus 1 in the denominator. So let's see what we get then. 8 times, open bracket, 0.5 to the power of 12. I'll exit the exponent, subtract 1, close the bracket, divide by, open bracket, 0.5 minus 1, close bracket to finish the denominator. And we can see that the total sum is 15.996, which of course, if you wanted to round to 3 significant figures, would be 16.0. Number 6. Eva invests $2,000 at an annual interest rate of 8% compounded half yearly. Now, this is going to be tough to fit in, but let me just remind you that the future value of the money, this is inside your formula package, is equal to the original or principal present value of the money multiplied by 1 plus, okay, now then we've got r over 100k taken to the power of kn, or nk, I can't remember which. And it tells you what all of these different things represent. So the initial investment is $2,000, and our r value is 8%, so that's 8 over 100. And the k is the number of times it's compounded each year, so 100 times 2. And then this k is 2, and how many years? It looks like after 5 years, so 2 times 5 is going to be your exponent. And that's going to be your future value of the money, so let's work it out. 2,000 is multiplying 1 plus 8 over 100 times 2. That 100 times 2 is all part of that denominator, so put it into its own parentheses, and then close your next set of parentheses to show that this entire expression, 1 plus 8 over 200, is being raised to the power of 2 times 5. And we'll get $2,960. And remember, only 2 decimal places, 0.49 when you round, as in any financial question. Although I suppose you could have also rounded to the nearest dollar, 2,960. And part B, find the number of complete years it will take for his investment to double in value. So the original investment of 2,000, has now doubled to 4,000. So we want to find out 8 over 100 times 2. At what point will it have doubled? So I have to write, let's see, doubling, it's compound 2 times x. There we go. Because I had before 5 years, now I've got to replace that 5 with an x, because I'm trying to figure out how many years it will take. So that's the only variable in the equation. Let's solve this with a calculator, so much easier. This is going to be y1, and all of this will be y2, and we'll find out where they're approximately equal. So here we go. y1 is equal to 4,000, the doubled value. y2 equals 2,000 times 1 plus, alright, 8 is being divided by this entire denominator of 100 times 2. Oh, shoot, I didn't see this part about Tony and everything. I've got to redo this question, or at least some things about it, don't I? For example, it's not 4,000 and 2,000, and it's not 8, and it's only compounding once a year because it's only compounding annually. So shoot, I gotta start this stuff again. Alright, it's 1,500 is now Tony's initial investment. Doubling means it hit 3,000, and his interest rate is 7.8%. Now I know that some of you like to write the 7.8 directly as a decimal, 0.078, once you move the decimal place twice. But then in that case, don't then write over 100, or else you're dividing it by 100 twice. Once to change the percent into a decimal, and then again. This divided by 100 in the formula is assuming that you're not converting your percent to a decimal, that you're just plugging in the percent value. Alright, and we want to know how many years this will take. So I'm just going to need to make some adjustments then. So my first function is actually only 3,000. And my second function is 1,500, and it's 1 plus 7.8 over 100, and that's being raised to the power of x. Okay, and I'm going to look at the table. The reason I'm going to look at the table is because even though the number of years could be a fractional number of years, that's possible, right, to have like 4.8 years, the question does specify complete years, which means that I am looking for an integer answer. So let's look at the table, and I'll find that it occurs on my 9th year. Oh, I don't have quite enough. On my 10th year, I finally do have more than 3,000. So I finally doubled my investment after 10 years. And if you excuse me, I'm not going to bother copying down the table. You've seen this enough times. You should know how to do it by now. Question number 7 is the difficult basketball question. So we've got a basketball. I'm just going to draw a picture. It falls for 2 meters. So that's my 2 meter mark, and then it bounces up to 90% of the value. So right here is only 90% of 2, and then it bounces up to 90% of the value. So now that is 90% of the previous one, which was 90% of 2, and so forth. So what height will it reach on the 8th bounce? Well, let's just analyze our terms. On the first bounce, it has gone to a height of 0.9 times 2. That equals 1.8. Right? There's my first term, my first bounce. Oh, hey, just a second. I'm just reading this again. It reaches a height of 2 meters on the first bounce. So this right here is your first bounce. That's your second bounce. That's your third bounce. Sorry about that. That means then that our U1, very first term, is 2. And our second term is 0.9 times 2, which you'll find is 1.8. And your third term is 0.9 times 0.9 times 2. Now that I think about it, I'm going to write my second term out as 2 times 0.9. And I'll write my third term out as 2 times 0.9 squared. You can see it's 0.9 of the previous term, which already had a 0.9 in it. And if I keep going, you should see the pattern that's developing. Obviously, that's U1, that's your R, and the 8th bounce means that n is equal to 8. So let's figure out what the 8th term is. This is clearly a geometric sequence, so your 8th term is going to be your first term times your common ratio to the power of 1 less than the term. And if we do 2 times 0.9 to the power of 7, you'll end up getting an answer of 0.9565938. 0.9565938 meters will be the height on the 8th bounce. We can of course round this to 3 significant figures, 0.957 meters. And then part B, what is the total vertical distance traveled by the ball between the first time that it hits the ground and the the 6th time it hits the ground? Okay, so let's trace what are the different terms that we're adding together. We're looking for the total distance traveled, and so that means that we have to add this distance to this distance to this one to this one to this one. 5 different terms that we're adding together. So let's look at the first term that we're adding together. It's gone up In fact, if you think about it, no, I don't actually want to say that after all. Okay, so the first thing that we're adding, we've gone 0.9 times 2, or 2 times 0.9, on the way up, but then it had to come down as well. So let's multiply that by 2. So in fact, the total distance traveled as it went up and down from the first bounce to the second bounce is 4 times 0.9, which is equal to 3.6, right? Now let's look at the second bounce. It's now gone 2 times 0.9 squared on the way up to its maximum height, and then it has to go that same height on the way back down to the ground. So that's now 4 times 0.9 squared. In other words, we've taken the previous term and multiplied it by 0.9 to get the next term, and we're forming another geometric sequence. Although this one, our first term is 3.6, our r 0.9, and how many total terms are there? 1, 2, 3, 4, and 5. And so n is equal to 5. So let's work out then, what is the sum of these 5 terms, where the first one was 3.6. We've got r to the power of n, which is 5 minus 1 over 0.9 minus 1. And that will give us the total distance traveled, 3.6 times 0.9 to the power of 5, exit the exponent, subtract 1, close the parentheses, divide by, open parentheses to make sure we're dividing by the entire denominator, and we end up getting a final answer of, to round it to 3 significant figures, 14.7 meters. And that concludes the review. Good luck studying for the test. You can, of course, also look at the review questions from the 2 quizzes that are also posted on this blog. All of those videos and questions you can look over. And there's also the 2 quizzes that you took earlier on this unit. So please do practice up arithmetic sequences, arithmetic series, geometric sequences, and geometric series, where the key to solving those problems is first identifying whether it's arithmetic or geometric, then writing down the formula that you should use based on whether it gives you or asks you for a term, so that's the U sub n formula, or if it asks for a sum or a total, that's the S sub n formula. So make sure you use the right formula for arithmetic or geometric, substitute all of your known values in, and then use a calculator to solve for the missing variable. If it's an exponential equations question, that means that you have to determine whether it's going to be growth or decay. You can use your calculator to graph it to find out various values. Don't forget that your asymptote is a horizontal line with equation y equals, and it will probably be y equals 0 unless we've shifted upwards or downwards by a constant, and then it will be y equals that constant that we added or subtracted to do the shift up or down. And of course then there's also compound interest, where we've already discussed the interest formula that's in the book, the formula package. So just substitute carefully into that, where you've got to look to see whether we are compounding multiple times a year, so that you would have to change the value of k. Otherwise it should be fairly straightforward substitution. So anyway, good luck studying these concepts, and we'll see you at the test.